Hi viewers, I am Savita Mary, Assistant Professor of Mathematics, St. Joseph College of Arts and Science, Kadalur. In this video, I am going to explain about the theorem, the set of all real number is uncountable. The set of all real number is uncountable. To prove this theorem, it is enough to prove the unit interval 0, 1 is uncountable. So, the unit interval 0, 1 is uncountable is enough to prove the theorem the set of all real number is uncountable. So, going to the proof for the unit interval is uncountable. So, here let us we will show this by contradiction. Let us assume the contradiction that 0, 1 were countable set. So, the contradiction is 0, 1 were countable. So, by the condition of countable set, we can arrange the numbers in the unit interval by the sequencing order x1, x2, x3, etc. Here the x1, x2, x3 elements are decimal elements, and it representing the decimal elements, and every numbers in 0, 1 occurs among the decimal elements. So, we define every elements in the interval 0, 1 should occurs among the xi. This is our assumption. Okay. So, expanding each xi in decimal expansions, we have the array like this x1 equal to 0.A11, and here the elements A1, A2, A3 are real numbers. Here the number A1, A2, A3 are real numbers, and the superscript mentioned by 1, 2 and n are the elements, the order of the element, the first element order, second element order and nth element order. And here we have defined all the decimal elements as 0 point something. Why? Because the interval 0, 1 inside the element 0, 1 all should be like a fraction 1 divided by n. So, 1 divided by n, dividing the number 1 divided by any number, it should be started with 0 point something. So, that is why we are define every element of x1, x2, x3 like a decimal of 0 point A1, A2, A3 etc. Okay. So, every element between 0 and 1 must lie there in the list. Okay. So, this is our assumption. So, every element, every number between 0 and 1 must lie there in the list of arrays. Here we are going to prove it is not possible, whatever we assume before is not possible. This is the process we are going to prove. So, to prove that we must find a number which is not lie in that array. So, for that purpose I have defined a number y is equal to 0.b1, b2, b3 etc. where b1 taken from this manner, b1 be any integer from 1 to 8 such that b1 not equal to a11. A11 is lies in the array which is the place, diagonal places. We have taken the elements in the diagonal places A11, A22, A33 and so on, ANN. Here B1 is not equal to A11. Like that way B2 is not equal to A22, and the number of integers lies in the number B2 should be 1 to 8, and in general Bn is not equal to ANN. Here I am avoiding the number 9. So, to define the number B1, B2, B3 etc., I am avoiding the number 9 because suppose I make a sequence terminating with the number 9, it may equal to the sequence of list of xi's, because if suppose the number 1 by 2 is equal to 0, if the number 1 by 2 equal to 0.5, you know. So, by decimal expansion we can write the number like 0.5000 etc., or we can write the number by 1 by 2 equal to 0.4999 etc. So, if you take terminating with the number 9 for another number, it may it may equal to the another number which is lies in the arrays. That is why I am avoiding the number 9 in this selection of B1, B2 etc. And now continuing this process, we can get the number y is equal to 0.B1, B2, B3 etc. Then for any n, this y is differ from the expansion of xn, the array expansion for xn, it was differ. So, bn is not equal to ann. Moreover, the decimal expansion of y is unique. So, it is not equal to any other number, it is unique number and it is differ from the decimal expansion of xn. That means it is not lie in that array. So, it is not lie in that array, so that this is contradiction to our assumption the set 0, 1 is countable. So, our assumption is 0, 1 is countable, but it is contradiction to our assumption. Therefore, 0, 1 should not be countable, it should be uncountable. So, we proved 0, 1 is uncountable, and this theorem is over. And continuing this, I am going to prove the set of all real number is uncountable. So, you have to prove set of all real number is uncountable. By contrary, I assume the real number were countable. If suppose the real number were countable means 0, 1 would be countable, because the interval 0, 1 is also the part of the real number. So, if the real number is countable in the sense 0, 1 is also countable, but this is a contradiction to the theorem. Therefore, the real number should be uncountable. By the theorem, the real number should be uncountable. So, we proved the theorem. Thank you.